Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about one. So try to learn a new concept in the me make yeah. So now let's try to learn about the new concept in the Node.js. That is nothing but multi-threading. Okay. If you try to observe carefully, all the times in your career and all those things, you will be able to see that Node.js is a single-threaded language. But you need to understand that Node.js is not a single threaded language. We can also implement the multi-thread using the Node.js. So let's try to understand how the CPU, how the threads and all those things work in the normally in the CPU. So let's try to see it. So before learning about this multi-threading concept in the Node.js, first of all, you need to understand about how the threads actually works and what exactly is the thread and how your computer or the system handles the process or the threads and why they are so important. So these all the things are very much important to learn. So have you ever wondered how your machine juggles all these open apps, stick around and all those things if you are able to see? So for example, let's say that you are having 4 or 5 apps running in your OS. So how this system can able to manage those all the process and all those things using the multi-threaded thing. So let's try to understand about this one. So let's get started. So understanding our threads and how your computer juggles these all multiple tasks. So normally we'll try to break down now in this video how your machine handles the multiple applications simultaneously. So if your CPU is having one core, two core or any cores, how many cores it may be. So if you're having, so how it can able to handle the multiple tasks. So for example, let's say that if your CPU is having only one core, so then that means only one process can be handled at a time. So if you try to open the multiple process or multiple apps or anything, how your CPU using only one core can able to handle it. Let's try to see. Let's go to the next step. So process versus thread. So let's try to understand the basics about the what is meant by a process and also what is meant by a thread. So what is a process? Every application, let's say that whatever it may be the application. Now I am sharing the screen, I am running this one, right? So whatever it may be, it is an application. So it is called as a process. That means it is an independent program with its own resources. So before we are talking about the threads and all those things, so we need to understand how your computer CPU and operating system manages all these programs you are running. So normally you will be opening a tons of apps right now. Right now in your system also, if you are able to see, you will be opening a tons of apps. So it may be a browser, it may be a music player or anything. Each of these is called a process. But how does your CPU, which might having just one core, handle them all? So that is where the CPU scheduling comes in. So let's try to understand about this one. And the next one is what is a thread? So what is this thread? These threads and process are something like super similar. In fact, Linux treats them almost one and the same only. So by understanding the process, how the process execute, so we'll also get what threads are all about. So what is a thread? Thread is a lightweight process to share resources that share resources. Linux treats them almost identically to processes. We'll try to understand what is a thread and what is a process going on. So just I want to explain you what is a process and also what is a thread. So now you need to understand the process states. So normally the process states, every process in your computer. So let's say that here you are, when I'm saying about the process and all those things, you think if it is an app only. So whenever you are running the process, so your computer, every process in your computer is in one of the three states. So either it will be in any one of the states. So you'll be having three states mainly. So the process will be either in one of the state. That is ready, running, and sleep. So what is meant by ready? The process is waiting for its turn to use the CPU. Think of it as a standing in a queue ready to go. So ready means it is ready to execute. It is waiting in the queue to execute it. Whereas running means the process is actively using the CPU, getting its code executed and performing its tasks. Sleep means the process is waiting for something like a file upload or a network request. It is not at all using the CPU at all. Your computer probably has hundreds of processes and they are constantly moving between these states. So these states only hundreds of processes will be moving between these states. So let's see them how it will be happening. One by one we'll try to see. So how the process works between the states here. So first it will be the ready state. So that you will be having a dispatcher in the OS. So this dispatcher will move the process from ready state to the running state. And running state, now the process, if it is blocking state, or it is waiting for any network or any file upload or something like that, any request is going, means it will go to the sleep. So there is no need for it to use the CPU. And then when it is completed, so when a event occurs or anything, the OS indicates it, and again it comes to the ready state. So your computer can have hundreds of processes constantly moving between these three states, orchestrated by the operating system. So this is all handled by the operating system only. So next one. So here I have told you about the dispatcher, right? So let's try to understand about this dispatcher. Let's say that imagine you got just one process running on your computer with a single core CPU. Okay. So let's say that here how it works. So when you open the process, it starts in the ready state, waiting for the CPU. Okay. And your operating system has a something called as a dispatcher. The dispatcher is the crucial component of your operating system. And here, so this one, its job is, the dispatcher job is, it needs to take the process from the ready state to the and move them to the running state. So that is the thing. And it allocates the CPU time, manages the transition between the states. So that is nothing but, so it will manage from ready state to running state, it will try to do. If the CPU is free, the dispatcher says that, hey, you are next, and moves the process to the running. The CPU starts executing its code. So that is the main state you will be having. So now process starts in the ready state. When you open a process, it begins in the ready state, waiting for the CPU. Already told you, right? So now dispatcher assigns CPU time. If the CPU is free, the dispatcher moves the process to running state, and the CPU executes the process for a tiny time slice. So now here the CPU executes the process code. So now here you need to understand that the process is executing. Let's say that it will execute the process code until the process is completed. It will not do it like this. It will try to execute for a tiny time slice only. That means around 100 milliseconds only the process will be executed, and immediately it goes back to ready or the terminated state after its time slice. So whatever the time it has been allocated for this one, so let's say that the process is there, it moves to the running state. Only the time given for this one to execute will be 100 milliseconds only by the OS. Within this 100 milliseconds, if the process has not been finished, it means it will again move to the ready state, waiting for that CPU to be executed. So after its time slice is completed, the process returns to ready state or finishes and terminates. Within that time slice, if it is finished, it means it will goes to the finish state or terminate state. So that is the thing. If the process is super simple, means like adding a few numbers or something like that, it might finish quickly and move to a terminated state, meaning it's done. But if it is a bigger task, means then the CPU gives it only a chunk of time only, called a quantum or a time slice. So it will be called as a quantum or a time slice. So usually it will be around 100 milliseconds. So that depends on the OS you will be having. After that, the process goes back to the ready state, waiting for its next turn. So the time slice is so short that you cannot even notice the switching. So you will be thinking that it is performing the multitasking. That's it. But the CPU performs only single task at a time. So here we need to understand about the quantum. So here the time slice or quantum is a tiny amount of CPU time given to each process, typically about 100 milliseconds. This slice is so short that you didn't even notice when the CPU switches between the process. Okay, understanding the sleep state. So now I told you, right? So now you understood about the ready state and running state. So exactly you need to understand what is a sleep state. What causes the sleep? A process enters the sleep state when it makes a blocking call, waiting for the external events like file creation or the network requests. So that means if a process is running, but it makes a blocking call, so like waiting for a file to be created or a network request to come in. So then the operating system says that, okay, you are waiting for something, no more CPU for you right now. So then it will move the process to the sleeping state. So while in sleep state, the process uses the zero CPU resources, freeing up processing power for other tasks. So now when the awaited event, so now here when the awaited event occurs, so now let's say that it is waiting for the request or something like that. So the request has been came, so that means an event will be triggered to that thing. Then immediately the process which is there, the OS moves the process back to the ready state and then to running to handle the event. So like this it will happen. Let's take a simple example with the Node.js server. So normally the Node.js server process flow, how it will be is, server starts and setup in the listen port. So whenever you try to write the code, all the middlewares and all those things setup will be completed. And whenever it comes to the server.listen, So it will move, the CPU will move it to the sleep state. Why? Because whenever a request comes, then only it needs to execute. Until and unless, so the request will be in the process will be in the sleeping state only. So it enters the sleeping state while waiting for the request. So let's say that when a request arrives, immediately the OS moves the Node.js to the ready state, and dispatcher moves it to the running state, handles the request, and then returns to the sleep. So like this, the process will happen actually. So now you will be having an illusion of something like multitasking. So here you need to understand, let's make things more real. So now you got hundreds of processes running, your browser, your music app, maybe game. How does a single core CPU handles all of them? So that is where the things come. CPU scheduler, it is the hero here. So your single core CPU isn't actually running the multiple processes simultaneously. It is rapidly switching between them, creating the illusion of multitasking. So that is the main thing. So how the multiple process work? So here hundreds of processes wait in the ready queue for their turn at the CPU. Each process gets a tiny 100 milliseconds of time slice before returning to the queue, and the CPU switches so quickly between the process that it feels simultaneous. So now here, who will give you the time slotting? So for example, a process has been moved to the running state, and I told you that around 100 milliseconds of time the process gets executed, and again it moves back to the ready state, right? So who will assign that time slot is the CPU scheduler. The CPU scheduler is the hero of your computer system, determines which process gets the CPU time next, manages the ready queue efficiently, ensures fair distribution of CPU resources, creates the seamless multitasking experience. So that is the main thing. So now that means it gives each process a tiny bit of CPU time. Those 100 milliseconds we talk about, that switches to the next one. Most processes are actually in the sleeping state, waiting for something like a mouse click, key press, or a network request. The scheduler rapidly switches them between the ready state and running process, so it feels like everything running at the same time. So that is the main thing. But really, the CPU is just super fast, like at juggling the process. So 100% CPU usage when running. A process in running state uses the entire core processing power. So your CPU usage when sleeping, a process in the CPU state uses absolutely no CPU resources. Most processes in your computer are actually in sleep state at any given time. So the lightweight champions here, the threads. What makes the threads so special? So threads, apart from this one, so what it makes that one so special is threads uses the shared memory, which we will try to understand about the shared memory and resources with their parent process, requires the less overhead to create and manage, allows true parallelism on multi-core systems. So we'll try to understand about this parallelism and all the things. In Linux, the process and the threads are treated almost identical to the processor. So that is what we'll try to see about these all the things about this one. But first of all, you need to understand the basic concept of this process, how the process will be executed in the CPU. So here threads versus process. So this is a simple thing which we'll try to do it. And here multi-core process. Modern CPUs have multiple cores, allowing true parallel execution. So this concept and all the things I will explain you. Each core can run a process thread independently. Scheduler distributes work across available cores, dramatically improves the performance for multi-threaded application. So real world examples are this one. So I will try to see the key takeaways now before wrapping up this one. So what we have learned in this video, first one is the process, different types of process states. So we have the each process in cycles goes through the different states, that is nothing but ready state, running state, and the sleep state as it executes. And another is CPU scheduling. The scheduler rapidly switches between process, creating the illusion of simultaneous execution. And thread similarity. Threads work almost identical to process but share resources for efficiency. Running process uses 100% of CPU core, while sleeping process uses none. So these are the things which we have learned. So common misconceptions is single core CPUs can run multiple processes at once. So you may be thinking that single core CPUs runs the multiple process at once, but the reality is that is not the thing. The rapidly switching between the process create an illusion of simultaneously. And all processes are constantly using the CPU. So you may be thinking that all processes will be using the CPU, but most processes spend the majority of their time in the sleep state only. So they will be ready state, running state, they will be switching. Threads are completely different from the process. In Linux, threads and process are treated very similarly. So many people will be thinking that process is different and threads are different. But in the Linux, I am especially telling you in the Linux, in Windows maybe it may be different. Threads and process are treated very similarly. More threads always means better performance. Too many threads can cause overhead and reduce the efficiency. So don't think that you are having more threads means it will cause better performance, but in reality too many threads can cause overhead and reduce efficiency. So we'll try to see about these all things. That's it guys about this one. So thank you for learning about the threads basic concept. So what we have covered in this video: process states, different types of process states, CPU scheduling, threads, and how your computer creates the illusion of multitasking. And these things only we have learned it. So if you have any questions, drop your questions about the threads or CPU scheduling in the comments below. And stay connected, subscribe and hit the bell icon to catch our next tech explanation video. Thank you guys.